Hi there and welcome back to Tripplikit, and today we are going to move on with developing a PCB using KiCad or KiCad, and we've got a schematic, so now let's turn that into a PCB. Okay, so here we have our schematic, and here we have our PCB. And as yet the PCB has only the board outline basically and the connectors on. So somewhere here there should be a button which allows us to forward changes from the schematic to the PCB. Okay, and here it is in Tools, Update PCB from Schematic. So, whoops, shall we hit that and see what happens? Right. Lots of errors. And we look down here, error. Cannot add R10, no footprint assigned. Well, that's fair enough. We need to tell it what the resistor looks like. Could be a tiny little surface mount or a great big power resistor. Okay, most of our resistors are these, and this is 0.1 of an inch or 2.54 millimeters per hole, so that's 3. So that's, these all want 7.62 between the pads, and don't want to start mounting them on end like this if I can possibly help it. And the only other resistor is this one, the power resistor for the current sense, which is 1, 2, 3, 4, 5 holes along, which is 5 times 2.54 in millimeters, which is, because I can't work it out in my head. Okay, so let us start assigning footprints to some of the resistors on our PCB. Okay, I've had a look at this to save you watching me go and it seems to be fairly straightforward. So we select, come on, there we go. We select the resistor, we look in Properties, Edit Properties, Footprint. So we want to be in Footprint, and that little button is for the library. The Footprint library, here we go. And because I've already looked, it's in resistor through the hole, and we want axial. Now P value there, I'm guessing, is the distance between the pads, P for pads, and L and D are the length and diameter of the resistor. So there we go, that's the one we want. And if we zoom in, and all I need to do now, how it is, select footprint to browse, insert footprint on board. Oh yeah, there we go. Double click on there. Oh, we don't want to show it. So let us go through all the resistors and it should come up with the same one, which is nice. So we do that for all the resistors except this one. And that guy is 12.7 millimeters P horizontal. Okay, we'll go with that one. It is a bit, I believe, longer than that. But that's the one we're going with. That's the important one, P12.7. So in we go. Okay, so I shall do all the resistors and bring you back. Okay, so done all the resistors. Shall we update PCB from schematic and see what happens now? Yeah, we know we've got a load more errors, don't we? RV1, no footprint assigned. So should we see if we can assign a footprint to RV1, which is that guy, and click on the middle of the component and just type E on the keyboard, and that comes up, which is a lot quicker than the way I was doing it before. So I shall see if I can find a footprint that actually fits the one we're using. Okay, well, I looked at the pot with a microscope and it does say 3296 on the side. Doesn't say Bourne's, but it says 3296. So I think for now we're going to assume it's a generic version of that, and ours is vertical, so that is the one we are going for. Brilliant. And onward and upward, let us look at update P for PCB from schematic. What next? C1. Alright, we're in amongst the capacitors. Okay, so here we have our little 100 nanofarad ceramic capacitor. The advantage of through the whole stuff is you can you've got room for wiggle and bending legs and so forth, so things don't have to be dead accurate. But anyway, this is 5mm P pins between the pins, which is the dimension we're most worried about, and ours is, I think, a little shorter and a little fatter than the one we've got here, but this'll do. This will do. So put that in there. Okay, so did that and did the other capacitor, the electrolytic. So run the update PCB again, and with J1, J2 and J3 are our next components that we need to find footprints for. Okay, J1, we need to work out what terminals we want to use, so we'll need to have a think about that. So let's look at J2. Okay, and here we have it. Pin header 1 by 5 by 2.54 millimeters, vertical, so it doesn't leave a large area of the board for the pin header to lie down on. So let's put her in. Oh no, hang on, I've realised I've made a mistake. There are actually 6 ways, not 5 ways. Okay, interestingly, let's see what happens if I ask it. And what happens if I... No, oh yeah, hang on. No, that's slightly annoying. Surely it should complain that the number of pins on the footprint doesn't match the schematic. So I think I'm going to leave those now just to see if it picks that up later, just to see how it copes with that. So now I want to find a suitable footprint for my screw terminal, so I will do that and show you what I've got. Okay, so this is the sort of terminal block I want to use for J1, just to get 8 wires in and out, 4 to the battery, 4 to the power. and these come in 5.08mm pitch. So if we go back into our schematic, select that, hit E, look for a footprint. Okay, so I had a look and this is the best I can come up with, which is the correct pitch and everything, but it's only 6 way and they only go up to 6 ways. So time to fire up the footprint editor and see if we can create one of something like this in 8 ways. So let's close that for now and close that for now. And the footprint editor is that button. Up she comes. Okay, so connector, no, terminal. So let's make a copy of the one we had. There it is. So file, okay, save as. Yeah, should we put it in terminal block, and we will call it terminal block 8 5.08. Hit save. Read only. Okay, so shall we in that case create a new library, and we can let's create a library called Tripplikit. Don't want one specifically for the project because I tend to try and reuse the same components in several projects. Global. Okay. There we go. There's nothing in it, so shall we try now and save this as what am I trying to do now? File name, save as type. Global. Don't know what it's done there. Okay, so I'll shut you off and find out how the hell you actually do that. So we have a new library, and we've looked at this battery charge. So I have created a PCB folder to put all my PCB libraries in, and you can see I've made a bat charger library, and so I won't make another one, and it'll ask you to make it whether you want it project specific or global. So I made it global so I can access components from other projects. And here we have the bat charger library. So we're now going to save this as the bat charger library, terminal block 8, P, etc. Save. And there we go. So now I need to add 2 more of these pins to it. Pins, terminals, whatever. And save it, and then it'll be good. So I shall again bring you back when I've figured out how to do that, because it may take me some time to figure out. Okay, as you can see, created 1 extra pad. So shall we create a second extra pad? So we're going to say copy, select reference point for the copy, the middle's as good as anywhere, and 1, 2, 3, 4, the grid is 1.27 millimeters, and if we find a paste, there we go. That's actually there where it is. So now if we right click and go in properties, pad number 8, and the hole size is 1.52, maybe a bit big, don't know, I'm gonna leave it for now. And there we go. So question is, how do we expand this? Do we just grab it? All right. Yes, no, okay. Knock off the grid. Right, how do we turn off snap to grid? Grid. Well, that's the grid. Okay, I guess I'm gonna have to find out. Okay, so I've started moving these graphic elements so they hook around the newly added pins. The cursor sticks to the grid, which means you can't really, or you can. So look at that white line, I can't select that because I can't get on it, and then this is supposed to. So that is now supposed to stick to the grid, and the grid is displayed as dots. But if I take that off, okay, it removes the grid dots, but the cursor still sticks to the grid. Now in this case, so for these I had to set the grid to the minimum so I can get on whatever. But this, it shouldn't be a problem, so I can really don't know. I don't think that's done what I wanted. Oh, there's 2. Okay. However, you can go in the properties and it'll give you start points and end points. So as long as you know where you're going, and we know we want to be, whatever is it, 10.16 millimeters bigger, we can just type the values in there, which is what I'm doing. So I will do that and bring you back. Okay, so there's my finished footprint and I've saved it. So should we try and add it to the schematic component? So bat charger, terminal block 8. Oh, there we go. I'm massively impressed. And there it is, it's in. So if we now run the what is it, forward to PCB, is it that? No. Tools, update PCB from schematic. We are left with J3. I did J2, so all I need is to put J3 to the same. And 4 diodes, which are standard diodes, so the footprints will be in there. So I am going to do those, and then we will reconvene. Okay. Update from no errors, no warnings. Shall we do it? Update PCB. Ugh! Close. So, there we go. Yes. So we've got a great big mess of components. So easy PC, put them all in a little parts bin to the right, so you could pull them out when you needed them. Okay, so I am going to leave them all there. And drag them in one by one. It's going to be tight. Okay, so our template PCB has some shapes already on it for USB socket, power socket, these jumpers, and not too sure what that's there for. Also some holes to mount it. So I propose to do two things. Firstly, put long enough headers on so that I can get component leads in this area of the board without them hitting the sockets. And secondly, I plan to say it'll be firm enough just with the headers pushed into those sockets, so I can do away with these 4 holes in our board and create a little more space, because as I said, I think it is going to be somewhat tight. And I can of course extend the board. There's nothing that says it has to be the same size as the Arduino here. So let us first do that. Okay, so if I were to we're back to going to the minimum grid, so we can come on. Right, can I have selected that? Yes. Okay. Alright. It's locked. I have to double delete to delete it. Okay. Oh, that's better. So you don't have to click on things exactly to select them. Right, so that's cleared my board space a bit. So am I going to that's good. Don't know. This is the problem. It's a sort of process of iteration. You've got to put things where you think they might go sensibly and then find There are lots of reasons they don't go there. Move them, find there are still lots of reasons. Till eventually everything fits together. Rotate clockwise. That's what I want. So, nip back to the schematic. Let us put D5 and D1 in. Let's see if I can find them. Oh, there we go. If we can select them. Okay. So they will go hopefully there. Right, and all these little lines are where the connections should go. But we might have to check the schematic. Okay, so we've got 2 diodes placed after about 20 minutes. Not a fast process. So now let us try and wire them in. So all these little straight lines are where they should go. So if we start there, okay, and there is one so that's no good, so that's on that pad. So if I come out of there, grab that, move it up. Oh, I'm guessing I need to drag 45-degree mode. Oh, that's good. Yeah, I like that. So there we go. We've got those 2 diodes sort of wired up. Okay, I'm gonna finish this video here. As ever, we haven't got on as far as I had hoped we would, but it's a slow process. I remember I've taken a week to make a few modifications on a reasonably complicated board, and also I am learning the software as we go along, and there are plenty of tutorial videos saying do this, do this, do this, and there you go, and you have a board with about 4 components on. So I thought I'd actually give a flavour of what it's like to actually learn the program, and I hope that's sort of complimentary and helpful, and you can see the process I've gone through to try and find how to do things. So that's it for this video. Subscribe, comments, thumbs up would be nice. So for now, it's goodbye from Tripplikit, home of interesting electronics. Goodbye.